This last section that you're going to learn about in this chapter is about solving these rational equations. So you've been multiplying, dividing, and adding and subtracting the expressions, but now you're going to be dealing with equations and you're going to solve them. So what you're going to do to solve these is you're going to multiply every term by the least common denominator, and then you're going to simplify. And you're going to factor the denominators before you find the least common denominator, because it makes it a lot simpler. So if you can factor the denominator first, do that. Just like before, anytime you can factor first, do it. Factor first. So we're going to look at an equation first that has just one solution. And the rule above was you're going to multiply every single term by the least common denominator. So if you look at all these denominators, we have x, 2, and x. First off, we can't factor any of these, obviously. You want the least common denominator. So to find that, just like you were before, first off, write what they have in common. Between all of these, 2 of them have an x. And then write whatever's left over. Well, we have a 2 here. So 2x is your least common denominator. So you're going to multiply everything by 2x. So I'm going to multiply this side by 2x and this side by 2x. And what that does is it gets rid of our denominators for us. It actually makes it really nice. Because when you multiply 4 over x times 2 over x, I'm going to rewrite this out. I'm going to write 2x times 4 over x. Plus, I'm just going to distribute this 2x, because this is really what you're doing. You're taking 2x times every single term. Alright, so when you multiply straight across, our x's cancel out. So your denominator goes away, and you just have 4 times 2, which gives us 8. Then you have plus, the 2 and the 2 cancel out, so you just have 5x, because you have 5 times the x. And then you have equals, the x's cancel out again, you have equals negative 22. Then just solve for x. So subtract 8 to the other side. So I have 5x equals negative 30. Divide by 5, and x equals negative 6. So it's a handy little trick that you're going to be using. Now we're going to look at a problem that when you get done solving it, you have more than one solution, so you have to check for extraneous solutions. But the process is the same. You're going to multiply every single term by the least common denominator. And this one's pretty easy. If you look at the denominators, we have x minus 2. This 7 is really over 1. And then an x minus 2. So the least common denominator is they already have, these two have a common denominator, which is x minus 2. And if you use our rule where you write down everything in common, which we just did, x minus 2, and the leftover, which is a 1, so you really don't write that down, our common denominator is x minus 2. So you're going to take everything times x minus 2 on this side and on this side. So if I write that out, I'm going to write it out just to make sure you understand what we're doing here. You're taking every single piece times x minus 2. Alright, so if I go through and multiply, over here the x minus 2's cancel. I have 1 on top, 1 on bottom, so I just have 5. So it works out nice. Right here I'm going to distribute my 7 through, so I have 7x minus 14. Plus, again, my x minus 2's cancel. So I just have 10. And it looks like we're only going to get one solution if you solve for x. So if you only get one solution, you don't need to check for extraneous solutions. We get x equals 9 over 7. Since we only got one solution, you don't have to check for extraneous solutions. I'm assuming I probably put the wrong problem in the wrong section. But that's okay. We just did another one with one solution. This next one you're going to see right away that one of our denominators we can factor. Once again, if you can ever factor first, factor first. So we have 12 over, this is the difference of two squares, x squared minus 1 factors to x plus 1, x minus 1. So to find your least common denominator, my tip again is to write down the denominators that are in common. So they both have an x plus 1, write that down. And then the leftover stuff. Well, x minus 1 is left over. And that's it, because this is just over 1. So this is your common denominator that you're going to multiply everything by. So I'm going to multiply this side by x plus 1, x minus 1, and this whole side by x plus 1, x minus 1. So when I go ahead and do that, over here my x plus 1s are going to cancel. So I have 4x plus 1 times x minus 1 equals, on this first fraction, I have this whole fraction times x plus 1, x minus 1, so my whole denominator and this cancel out. So I'm just left with 12. Plus, I have just a 1 here, so nothing cancels out, so I have 3 times my whole denominator, x plus 1, x minus 1. So your next step in solving all this is foiling and distributing and all that good stuff. So over here we're going to FOIL these two binomials. So I have 4x squared plus x minus 4x minus 1 equals 12 plus, if I FOIL this out, it's going to be x squared minus 1 and 3 times all that, so I'm going to distribute my 3 right away, so I have 3x squared minus 3. So then to solve for this, I'll add all your like terms together, so I'm going to subtract my 3x to the other side, so I have x squared, and this x minus 4x becomes negative 3x, and move all my constants to the other side. I'm going to have minus 10 equals 0. I noticed it equal to 0 because I have a quadratic here, an x squared, x, and a constant. So if I factor this out, I'm looking for factors of 10 that subtract to give me 3, which would be 5 and a 2. This negative means opposite signs. This negative in the middle means I want the bigger number to be with the negative. So if I set both of those equal to 0, my solutions are 5 and negative 2. Since I have two solutions, this is OR, I need to check them to see if either of them are extraneous. So we're going to scroll back up to the original. We're plugging in 5 and negative 2. Checking to see if they're extraneous. So if I plug in 5 first, we're looking at the original problem now. Anytime you check extraneous solutions, you should plug it in to the original problem. So if we do that math, we have 21 over 6 equals 12 divided by 5 squared is 25 minus 1, 24. So a half plus 3. 21 divided by 6 is 3.5, and 3 plus a half is 3.5. So this works. So we need to check if negative 2 is an extraneous solution. So now I'll plug in negative 2. Which we get this side to be 7, equals, believe it or not, 7. So both these are solutions, which is possible, and that's okay. So both x equals 5 and negative 2 are solutions. If this did not equal each other, it would be an extraneous solution. The last one I have for you is another strategy you can solve by cross-multiplying. Cross-multiplying works the best whenever you have a constant over an expression. Here we have constant on the numerator on both sides. And again, anytime you can factor, it's going to make the problem easier. So on this side, we have x squared minus x. You can pull out a common factor. We can pull out an x So we're left with x minus 1. In the end, it's just going to make our problem a lot simpler. So we go to cross multiply. So we have 2 times x minus 1 equals x times x minus 1. And you're going to see that it was nice to simplify because we have an x minus 1 on both sides. And if we're to solve for x and we divide by x minus 1, that's just going to cancel on both sides. And we're left with x equals 2. Actually, the rule is if you have all multiplication on both sides and you end up with a binomial that's the same, you can actually just cancel those out. So you would have been able to look at this and say, oh, it's all multiplication, everything's multiplied together. There's no pluses or minuses. I have an x minus 1 on both sides, you can just cancel those out and write x equals 2. Because you're going to divide, it's going to cancel out anyway. So that's a nice simple problem if you have a constant over an expression like that. But again, always factor if you can factor first.